In a saltwater fish tank is very challenging, and one of the main challenges you have is maintaining a good calcium concentration. The solubility of the calcium carbonate really limits how much you can put in, and if you don't have enough, then the corals can't pull calcium from solution to grow their skeletons, which are underneath the colorful polyps that draw people to these corals. So you end up testing your calcium level in your tank regularly and then adding calcium if you're falling short. One of the popular kits for testing calcium is this calcium test kit by Salifert, and it operates based on a relatively simple titration. They give you a little 1 milliliter syringe, and this is going to sort of double as what you might think of as the burette, and a little vial, and you put some water in the vial, you add some sodium hydroxide, they give you a little scoop of that, and then you add some indicator, and it makes this sort of red rose color, and then you start dripping in EDTA from the syringe into the test kit, and you look at what the final reading on the syringe is, and they provide you with a nice little calcium table, and you can read off your concentration. And so let's do this by hand and then compare it to the table. So the volume of sample that you use is a 2 milliliter sample of the water from the reef tank. Okay, and you add it to the vial, add some sodium hydroxide and some ureachrome black indicator. That's just the chemical powder that you put in there. The syringe is initially filled to a volume of 1.00 milliliters with the 0.0250 molar EDTA. That's the titrant. Okay, and the trick is that neither the 1 milliliter or this 0.21 milliliter are the volume of titrant that you're using. So we have to do a little subtraction. And if it initially read 1.00 and it reads 0.21 after you've added everything in, then you have 0.79 milliliters of titrant that you're using. Okay. And we're trying to get, in this case, it's a part per million of calcium, so it's going to be a little different. What I'm going to do for starters is, well, I guess I can put down the parts per million is the grams of calcium over the grams of solution. So we're going to try to get to grams of calcium with the dimensional analysis. And we're going to start not with calcium, but with the EDTA, and we're going to start with the milliliters of EDTA that are used. Two chemicals. It's going to be a mole-to-mole conversion. Going from moles of EDTA to moles of calcium. I can then use the atomic weight to go from moles to grams, and on this side, we're going to use the molarity of that titrant, the 0.0250, and the SI prefixes. And that should let us get from the volume of EDTA we used to how many grams of calcium were in that initial sample that we put in the vial. So we started with not 2.0, that's the volume of the calcium. We have the 0.79 milliliters of EDTA. We're going to use the SI prefix to change that to liters. And then go from 1 liter to 0.0250 moles. That's the concentration of the EDTA. And I'm not going to write out the balanced chemical equation. EDTA stands for ethylene diamine tetraacetate. It's a big molecule, but it's known to react in a 1-to-1 ratio with most metals. And so in this case, 1 mole of EDTA will react with 1 mole of calcium. Okay. Then we're just going to use the atomic weight that the 1 mole of calcium is 40.078 grams. And so let's see where to go. 0.123 zeros, then 7915 grams, and I have two significant figures from that 0.79 milliliters at the start. we're going to come down here, and it's not going to quite end up grams of solution initially, but I'll have the 0.00079115 grams of calcium. I can put that directly in. And I'm going to go ahead and put in my volume of solution, which I can then change to mass of solution. So let's see, this was 2.0 milliliters. And I know from my density of the tank, which would have been measured separately, that it's 1 milliliter is 1.025 grams. The specific gravity was 1.025 using one of those dial hydrometers we used in the first experiments. And so when I punch all these numbers in, oops, I have to put a times 1,000, a million parts per million. When I punch all those numbers in, I get 386 ppm. It should be 2 sig figs, so 390 parts per million. And if I look at that, the 0.21 would fall right in that, in between these two measurements. Should have been around 395, but we're very close to what the table would tell them. So the table's there so people don't have to do dimensional analysis and stoichiometry. But it's just a titration like we're learning in the lab that's been commercialized by putting it in a package with a more convenient volume than a 50 ml burette and a little table to make the data analysis easy. In this case, we're right near the bottom end of the acceptable calcium range, and it's probably about time to dose a little more calcium in the tank.